Self-management of certain functions reduces the need for management intervention, clearly simplifying life not just for application developers, but for network administrators as well. Everything listed so far relates to lowering the total cost of ownership. However, as previously mentioned, manageability can also impact the revenue side of the equation. Threshold crossing alerts allow early and proactive reaction to performance degradation. This can result in higher service levels and ultimately higher revenues. Comprehensive data collection capabilities in the device to provide detailed data about service levels can be used in accounting and dispute resolution. Support for resource partitioning enables network providers to divide a device into multiple logical devices and might facilitate providing a new types of services altogether, such as virtual router services. Finally, manageability can be a factor that contributes to the availability of networks and services. Manageability features can help reduce the possibility of availability being affected by accidental operational errors. They also help accelerate problem diagnostics and repair to minimize downtime. Increased availability in turn increases customer satisfaction and leads to increased revenues as well. Concurrency support within a device and across devices facilitates coordination between competing management applications. Concurrency support includes the capability of management applications to lock parts of the configuration for their exclusive use. This helps avoid situations that result in inconsistent network configurations and services outages from multiple management applications that unintentionally conflict with each other. Integrity checksums help avoid outages from corrupted configuration files. An integrity checksum is a number that is computed from the rest of the file contents and then appended to the file. The basic idea is that if the file has been altered, this can be easily recognized because recomputation of the checksum will lead to a different number that does not match the one that was originally appended. Input validation. Syntax and semantic checks before actually attempting command execution helps avoid outages that are caused by invalid commands sent to a device. This is particularly important when there are groups of commands that can be submitted to a device for execution at the same time. Rollback capabilities allow managed devices to automatically fall back to the last known working configuration in case of a configuration error. This allows devices to recover from errors that were not caught or avoided by other means. Self-management capabilities decrease the dependency on external network managers and management applications, which also avoids operational errors in untimely management actions that could affect availability. And again, threshold crossing alerts allow early reaction to degradation of performance before availability is impacted. In many cases, the same manageability features contribute simultaneously to several goals. For example, support for threshold crossing alerts affects not just operational costs, but also the capability to generate revenue as well as network availability. Management systems and operations support infrastructure. We now take a look at management applications and identify what types of properties affects management effectiveness at that level. As we did in the case of manageability, we turn to the cost side of the equation first. It must be recognized that management systems are themselves a cost factor. Even if that cost is more than offset by the benefits they provide. The following are some of the aspects that affect the cost associated with management infrastructure, most of them completely unsurprising and in line with that of other business software applications. The capability of a management application to scale. Management applications that scale well might reduce the number of hosts that are required as part of the operational support infrastructure. This lowers the secondary cost of needing to manage that operations support infrastructure itself. Management applications that scale well also facilitate build-out of the network itself because this build-out is less hampered by issues relating to the capability of the operations support infrastructure to keep up. The capability of a management applications to be distributed across multiple hosts. This can be one cost-effective way of allowing applications to scale because it is possible to simply add hosts instead of needing to upgrade to a larger and potentially much more expensive host. Use of low-cost operating systems, hardware platforms, and databases. Capabilities that facilitate management of management systems themselves. It is important that the task to manage the operations support infrastructure does not unduly distract from the management of the production network. Features that facilitate integration into operations support environment. Perhaps most important, this includes support of 4 comprehensive northbound interfaces, properties that those interfaces should possess to facilitate an application's integrations with other systems largely mirror those of management interfaces of the managed devices themselves. The capability of a management system to integrate with different systems can simplify workflows and avoid the need to enter and maintain redundant data. Productive user interfaces can help network managers accomplish more. One aspect to consider is that in many cases, the productivity of an interface depends on the target user. Occasional users require interfaces that are easy to learn and understand, often relying on drop-down menus, GUI wizards, and elaborate graphical displays. Power users, on the other hand, might find the same interfaces slow them down, preferring interfaces that are more character-based and that offer plenty of keyboard shortcuts. Programmability and customization of management functions enables network managers to automate routine management tasks. Features that assist users to sift through large volumes of management information enables management by exception and further increases productivity of network managers. Examples of such features include this: visual highlighting of information that seems out of the ordinary just in the case of manageability. Management applications are not only about reducing operational costs. There are also ways in which management applications features can help increase revenue. One technique to improve provisioning throughput is to support concurrent communications with multiple devices, which allows the provisioning applications to direct provisioning requests at multiple devices simultaneously instead of having to serialize requests. In addition, in some cases, network management can itself be a service feature that a service provider might be able to charge for. A service provider might offer facilities that allow customers to provision certain aspects of their service. For example, to add bandwidth to a link in a virtual private network in a self-service fashion. Such capabilities are sometimes marketed using labels such as customer network management. Finally, many management systems features can help increase a network robustness and availability. In fact, this is one of the very purposes of many network management applications, such as fault management applications. However, other examples apply to a much wider range of management systems. For example, checkpointing, audit logs, backup, and restore functions allow management systems to more quickly recover from failures. In addition, management systems can perform a significant number of syntax and semantic checks before sending requests to managed devices, thereby decreasing the chance of introducing inconsistent network configurations. Functions to sort, search, and filter information according to a wide variety of criteria. Graphical representation of large datasets, for example, through diagrams, curves to visualize trends, and the like.